So, I'm Steve Spencer. I'm from Liberis. So I'm going to talk today. This session is about what machine learning is, give you an overview of Azure Machine Learning, look at a few things that other people have done, look at how me as a developer can help my colleagues use this sort of tools. I think the first thing I want to say is I'm a developer. I'm not an analyst. I'm not a data scientist. I'm not a mathematician. So if you're one of them, you're probably going to know a lot more about this than I do. So building models and all that sort of stuff around it that's not what I'm going to talk about today, because that's not where my expertise is. So I'm actually going to assume that you guys are all developers. So that's the level I'm trying to set this at. So what is machine learning? So it's a technique that allows computers to use existing data to actually then predict future values of a set of data. So, for example, credit card fraud. You've probably had phone calls from the bank saying that transaction doesn't look right and give you verification. They're using machine learning to sort of work that sort of thing out. I think there's two things that come out of that. The first one is a prediction. So you'll get a value back or an answer back, and it's not always right. And you'll get some sort of percentage value to sort of help you decide whether that value is something worth looking at or not. And the other thing is it actually needs previous data to be able to train it and to help you work out, sort of train that algorithm to make it work how you think it might work. And actually using the machine learning process is fairly similar across a lot of tools. So you need a way of getting your data into the process. You then need to do something with it. So tidying it up, making sure that the data is consistent. If there's missing data, what do you do with it? Maybe put it into a different format. Then you use some sort of algorithm, and you use that data set or some of that data set to teach using that algorithm to sort of get a set of answers, so you can use that model to work out whether your new data that you're going to get is to sort of compare that with. And then you'll keep some of that data back. So you want to, I don't know, say 75% of your data used for training, 25% used for testing. So you'll run that through the algorithm after you've trained it, and you'll look at the answers you get and compare with what you should have. You should have in that data set the thing you're trying to work out. So whether that's a value, whether that's like a type or whatever, you'll have to have that answer so you can work out what it is, and you can do that comparison. And then a lot of times that's all that happens. So somebody's built something and pushed it in Excel or SQL or something, and it's out in a box somewhere that somebody manually does it. So what we actually want from a development point of view is to be able to deploy that and then use it, and actually use it in your applications, actually make use of these techniques. Once you've got that, you need a way of improving that model. So as you get more and more data, it's really good to then retrain it with that and actually improve what you're trying to do and maybe tweak it a little bit, and then you want to redeploy it. So that whole excuse me, that whole process is sort of fairly standard. And actually there's two parts. If you look at Azure now, there's two parts. There's Azure Machine Learning Studio, and that's the bit I'm going to sort of concentrate on. And then there's this new thing that's in preview, which is a service, and that's more geared to people who understand machine learning a lot more, and it gives you an environment to do that in. So, nice one. And that's sort of gives you a Python environment, and you can connect your tools up to it that you're used to. Version control uses Docker to help you train and deployment, but it uses a similar sort of process to what we've just talked about. So, but the ML Studio is actually a really nice way of at least getting into it. If you're not familiar with machine learning, you want to play with it, then it's really easy to use. So it gives you a drag and drop user interface, and it's got bits of components you can drag in for each part of that process. So you've got your data ingress, you've got your data transformation, your cleansing, things for teaching, evaluating, and then deployment. And you can actually build them in the environment. You can run on the data set, and it will give you an answer, and you can look at it and view that pictorially in graphs, or you actually look at the data. So, and once you're happy with it, you can then push that out and actually deploy that out as a web service. If you're a bit more of a data scientist, then you can use R and Python models if you've got them already. You can use those in there. But there's a whole load of built-in stuff. So there's a whole load of algorithms in there that you can just plug and play and use. And there's a free subscription as well. If you want to actually just get on with it and play with it, you get a limited amount of resource, but it's not a lot of money to use a paid subscription anyway. We'll talk a bit about that actually. So I've sort of touched on things like models and algorithms and this sort of thing, and the biggest thing for me is like I don't really understand it. So it's sort of what would you use each of these models for? So the first one is I've got a value in a range, so I want to predict what that value is going to be. So that's like, what's my profit going to be in 6 months' time, for example? A number, so it's not necessarily a fixed answer. So what we'd use for that is an algorithm called regression. So you'd run a regression model, and you'd put that against your historic profit over the last however many months you've got the data for, and use it to try and forward predict what you're going to get in 6 months' time. Then there's the next one is what's called the classification. So this is like, I've got something that could be one of these, could be one of these, could be one of those. Which one is it likely to be? And you've got a couple of things that you've got two class. So that's normally a yes, no. So it's like, is my tyre going to burst in the next 1,000 miles? Or you've got a multi-class. So I've got lots of different things there. Is it a, I don't know, car, lorry, or a van, or whatever? If you've got pictures, you might be looking at that sort of thing. That's called multi-class classification. You then got something called anomaly detections. This is similar to what you get with your credit card fraud. Is they're looking at patterns of data and seeing where something doesn't look right. So if you suddenly have a big expense somewhere in like where you're not expected to be, maybe in the States or Russia probably, they might think that's a bit of an anomaly and ring you up and see whether you've been over in Russia and whatever. And then the final one is how is your data organised? Is the groups, looking at the data, it's not always obvious, but are the groups of things that are related based upon the data? So that's called clustering. So you've used Azure ML Studio, you've got your data in, you've done your tidying up, you've filled any missing values out, you've built your model and you've trained it, and you've ran your experiment through and you've tested it, and it's given you the answers you want. You can now deploy this as a web service. So it's really one of the nice things about this is it's not now sat on somebody's Excel somewhere running a model, or they've got some Python running on their machine. You've now got something you can call from a web service. So you'll get a URL and a key, and it's just a normal web request. So you pass all the data in that you would use. And actually what you can do is then export and import that. So one of the things we've done is actually taken that web service, exported it into a different subscription, so our data scientists can't actually push anything into production. So we've sort of given a bit of, taking some control back, given them something and then taking it away. So, but you can also test that. So you go into the portal and there's a nice little web test thing, so you can populate it with all the data fields you want, hit test, and it will come back and give you an answer. So it's quite a nice sort of little environment just to sort of get things moving. So this is Azure Machine Learning Studio. So you have a number of tabs down here. So I guess the first tab that's probably going to be of interest is data sets. And what you need to do is in order to use machine learning, you need a set of data. So I've imported some data. This was free. I think it's American census data. So you basically get a whole set of properties of each person, and we're interested in this column here. So what's their income going to be? So this is actually a two-class classification because it's got either less than 50k or greater than 50k. So we're interested in which one of those are they likely to be based upon all this other sets of data. So if you're looking at the data, it's not actually obvious what the answer would be. So if you just had a look at it and tried to predict yourself, you probably wouldn't get it right, because you'll see something, oh, there's a pattern here. It's all people who are husbands that live in the United States and less than 50k or whatever. You would never find that sort of pattern by looking at it yourself. But there's other fields in there, so there's all this sets of data, how many hours they work and everything like that. So trying to look at it and see those patterns isn't going to actually help you really. So what we need to do is find a way of using that data in machine learning. So you basically click on new, and then from a file. So I could go and pick that file that I just looked at, upload it. I'm not going to do it now because I've already done it. And we want to use it then. So, oops, not expert. So in the studio, we build something that's called an experiment. You can see this is one I've created. I'll go through this anyway. So we can create one, and you can actually build it based upon a whole set of pre-built one. So these will use some of the data sets that are free that you can play with. But I'm just going to create a blank one, and you get an empty workspace. So I could go in here and say, change the title, and then just basically drag and drop things in. So the first thing I need to do is drag that data set in. So it's fairly straightforward. Just grab it and pull that in, and I can visualize that. So if we look at that, it will show you pretty much that same data that you've seen. Limitation on this, though, there is a limitation on the number of columns that you view and the number of rows that you view. So you won't be able to look at this to view all your data. You can just use it as a sample just to make sure it is what you want. First thing I want to do is actually I can't find it. There we are, data transformations. I want to clean that data. So some of those fields, if you notice, some of them don't have values in. Some are 0, some are question marks. So we can actually do something with this data if we wanted. And what I want to do is actually I'm just going to say, I'm going to wire that in. So you just drag that down, and that's going to pass all the data through into here. And you've got some properties you can set up. So you could pick which columns you wanted to clean. So if you knew there was one column that was always causing you a problem, then you could pick it. But I'm just going to pick everything, and all I'm going to do is you can decide what you want to replace it with. But I'm just going to say replace it with a value of, I don't know, let's just give it some data, and what that will do is anything that's missing, it will replace it with the 3Gs in there. So now at this point here, I could run this, and then I'd be able to see that data cleansed with the GGG in for whenever there's something whenever there's something missing. Oops. So you see there's a couple of different things in here. What I want to do is actually take the clean data set, and I want to split it. So this is where I was talking about we need to have a set of that data to train and a set of that data to test. So we need to have a fairly good sample of data that we can feed into whatever algorithm we pick to then say it builds a model, it does the training. Then we need to use the other part of that data to run it through to see where we get, whether that algorithm's any good, and it gives you some sort of value of how accurate or not the algorithm is. So let's just say I want to make that. So I put 80% in there. So 80% of the data is going to be used for training, and the other 20% will be used for testing. So going to find it. There we are, train. So I want to do a train of this model, and you see there's two inputs to this. One is the data set, so I want the output of this. So we have two outputs from the split. So one is the first one is the data that we've split, that's 80%, that's the training data. So that, and actually this shows you, I can only join it to that one when I click it. The other half is what I would use to do the scoring a bit later. But I need to put an input to this, so this is it allows me to put an algorithm in, so whatever algorithm I want to pick. So remember I talked about the different types of algorithm we wanted. We wanted to pick a two-class classifier because I want to pick whether it's less than 50k or greater than 50k. So we go into classification. You'll see that there's a whole set of them. So we're interested in these bottom few here. So they're all. I mean, this is where it gets. I'm not. My comment at the beginning is saying I'm not a mathematician. I don't really understand what these algorithms mean. So they all do something different. I have had an analyst friend explain them to me, but it was like it went in this ear and then out that ear. So until you start using them a lot, it's difficult for me to be able to comment on which one are the best ones to do. So we'll pick that boosted decision tree and drag that on. And now what I need to do is wire that into there. So what that's done now is it said, I'm going to take that 80% of data, I'm going to use this classifier to train the model. So the output of this is trained data. So what I need to do now is do a comparison with the test data. So I'm going to wire the trained model into there. So again, it's got two inputs, and it only allowed me to connect to one. And we pass that into there. So what's that going to do is take that 20% data and compare it with. It's going to try and do a prediction based upon the answer, because it's already got the answer in there. You can see it's already got the less than or greater than. So it's going to use that to evaluate whether the algorithm's is any good. And you'll get a percentage based on what it thinks the answer is. And then the final bit we need is a evaluate. And what that's given us there, why has that got, oh no.
How have you told it which column was the result?
That's what I was just about to say. See that little red bit there? I forgot to do that. So the same thing, the same column selector. So what I want to do is I forgot what it was called. It was called salary, I think, was it? Or
How can we split it? Put the right answer next to all of them.
What do you mean? It splits it randomly. So when
we couldn't just do it against all of it and then compare it against the.
you need to have a model to train with, then it runs the other set through as a test, and it so it's usually one set as a training algorithm, the other set as a test. So it will then do a calculation and work out what it thinks the answer is, and you can do a comparison then to see whether how close or not. It's come up. So it's income. So I'll pick income column. So what this is going to do is it's going to use that income column and compare and build the model based upon what the value is on that income. So this is I've now got a complete model, and I can actually run this, and what this will do is it'll take that data set, it'll do that cleaning. So you'll see it move down. So it's up here at the moment. So when it starts up, this will clean the data. We'll clean the data. It's using because this is on a shared. It's on the. I was jumping now. It's on the shared services. It's not dedicated at this because I'm using my free workspace. So it's done the training. It's now looking at the scoring. We've got ticks all the way down, and if there's an error, pardon me, if there's an error, you'll get a cross on here, and then you'll be able to see. This is more specific. I mean, we've done some work with using Python models in here, and you'll get an error, a Python error, for example. You can actually diagnose it in this side. You'll be able to see it. So that's finished there. So we could actually look. I can do a visualize at this point. So in here we should see data with but I can't find any with GGs in. No, but that will have populated that data with the right values. You'll be able to see each of you could look at which data fields have been used for training, which have been used for for scoring. I don't if they notice there were a different set of values there. And then the actual one we're interested in is this evaluation. So we can visualize that, and what this will do is giving me a graph. Now, the steeper this curve is and closer to the axis it is, the better. So we could tweak the model. There's some parameters in there, but this is where I was saying I don't know enough now to be able to do this. But what I've been able to do is build a classifier, and is it this one? One of these gives you the output. So you can see this is said that it thinks it's less than 50k, and it's basically, if it's less than 50%, it's going to do one of the values. If it's greater than, it's going to do the other. So these are all less than 50k because it's less than 50%. So this one's here's one that it got wrong, but it was quite close there. The score was 47%. We've got one here that's over, another one over, and you'll see there's a different one here. This is quite a way out, this one. So for some reason it's predicted that as an 8% certainty that it's greater than 50k. So like I said before, it's a prediction, and you've got to. It's not 100% right. So we can train the model, we can tweak the model. So you can see this is where I said if you had errors, you'd be able to look at the logs and see them in here. But it doesn't really mean much because it's just a built-in algorithm. So if you've got your own Python or R code, you can add logging and tracing in and actually view what's gone on. So that's built my model. So that at the moment that's just something that's sitting there in Studio. It doesn't really do anything. It just allows me to view it. But what would be really useful is to make this into a web service that I can call in my code. So this is quite nice actually. It goes and builds this model into a web service model that I can call, and you'll see that this has changed the name here, and actually it's kept. We should have both. So this is the model I created originally. And you see it's now got two tabs on here, so it's got predictive experiment, and this should be the same view with all the web service parts in. So this has added the web service bits in, and it's packaged up all that model into a way that this can be used. So we could actually deploy that now. So this will deploy out to its own. I need to run it. Sorry. So you run this the same way. So it's running the algorithm, it's setting everything up, and it'll allow me to then, once it's run and passed, be able to deploy it out. And again, you can see it's got the ticks when it's done. So this is coming through. So I can now deploy that. So what that's going to do is create a web service, and it'll allow me to then, in my code, then call it from code with a HTTP client. So change this slightly over the. There we are. So what I need to do is go into here. You'll see I've got a primary key, and I've also got a web address that I can use. So there's a web request response, so you can actually send a batch file. So I think you can upload a CSV of that data that you want to score and put it into blob storage, and it will. Let me just check that. I think it is into blob storage. Yeah, so you get storing it in blobs. So you can see it here as well. I've got sample code to be able to access it. So the C#, you've got Python and R as well. So it basically gives you the code to call. But I've created a little test app, and I've actually got a number of services already deployed, so I can add a new one fairly easily. Let me just do. So we'll call this and then we will take the don't actually need all this URL, I only need to there. So paste that into here and copy that key. And the code that I've written is pretty much what you saw in the example. So all I've done is I've created a UI that allows me to set some of that data. And you can see some of it's blank. So we should see in the output that we get these filled in with those GGGs. So if we run this, so brilliant UI again for me. So we'll pick the .NET Sheffield version, and I can go through and just pick some of these values, which is pretty much what was in that spreadsheet. It's the same values. I just randomly pick them. I don't actually know what the answer is going to be. So, and I can click Get Salary Band. So this is now going off to that web service, and you can see it's got the GGGs in. So that's the using the service that I've just created. And this one says it will be less than 50k, and it's quite a high, or quite a low value, but which means it thinks it's quite accurate because it's like less than 1%, based on that set of data that this person is going to have less than 50k. So we've got another, just call a different one. So this has got different values for the missing ones. And you notice this also has less data in it. So the output data, if you spotted it, so there's more data in this one. And that's because you can actually, as part of that, the experiment, when we create this predictive one, we can add a can't find it. There's basically there we are. Select columns in data set. So I could add that in and do my selected columns thing. So I can pick which columns I want to. So either all of them or a subset. So I don't necessarily need all the data. So things like there was capital gains in there and something else. We made a decision that data is not actually relevant for this algorithm. So we've omitted it. So you can filter that down if you want to. I think that's that for the demo. What else have we got? Just make sure. Yeah, so I could actually. We'll do one more thing. So just to show, I'll go back into here, and we will do I'll make a change. So let's change this to be something else. So we'll change to JJJ. We'll run this, and then I'll So this is like retraining the model now. I've made it. Well, it has to be retrained because I've changed it. So changing the data set. So this is going to run through. So I need to run it, then redeploy. So we're getting there. Come on. we will get this retrained. There we are.
Running, can I ask, can you write this as code, or do you have to use the visual editor?
This version, you use a visual editor. It'll export it as a resource template, so you can deploy that manually, or you could edit it manually. But the other thing I was saying that's in preview, you can use it in Python and build the models in Python and integrate straight into the service that way. Okay, so that's run. I will then do the same thing over here. Oops, I need to get rid of that. So that's run, and I can do a deploy. What this should see now, it says overwrite. So that if you consider this tool as something that you would give your analytics team to do, and they're building web services, you've just given them a way of upgrading the production web service by clicking on that button. So it's one of the things that I'd like to try and talk about in a second about how we can make that better. So in theory, if I click that, it should not work at all. Well, that didn't upgrade. My demos are doing really well today. We'll leave that and we'll move on. I can create a set of experiments, I can train them. I can pick an algorithm now. I know enough to be able to say, I need a regression because I want a value, or I know I need a classifier because I want to pick one of a number of values. So I've got that understanding. And I can deploy that out now, and I can build my applications around that web service and build some useful functionality in. So I know how to do that, but I don't actually know whether that web service is any good. I had that nice graph which looked pretty good, and I could look at the data, and it's given me quite a lot of values that are right, but there is the odd ones that are wrong. So I don't know enough about it, and there are ways of tweaking that model so that I get a better answer and do other things and whatever. And I've shown this tool to a number of guys who understand all this, and they suddenly take what I've done and go blah, 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 and there's loads of other stuff in there, and they're saying, see this graph here, it's so much better than the one you had. I'm like, yeah, okay. But I can show that, so I have the skills now to pass that knowledge on to show somebody else how to use it. And I can also use models that other people have built. So we can import those models. There's a marketplace as well. So if something's there that you want to use that's really useful, you can pull that in. But what I can do is I can give the analytics guys some engineering process and sort of give them a bit more rigor to what they do. So that's why I pointed out that the fact that they could do the deploy themselves, if that's the one they use in production, they can go and tweak the model and push it in production. Suddenly everything falls over. It'd be down to you as a developer or whatever to then go and try and work out why, and it's actually they've done a change. So we've put quite a lot of process in there so that they can play around with that, and they can have their own web service. We can have a little test app that they can play with. But when they want to put it in production, we need to do something. We need to help them. We need to give that bit more sort of automation there, a bit of. So I think what I've got to is you can work with people who know how to do all the data science bit. I can show them how to use the tools. I can help them. They can help me understand better the data science side of it. And I understand it a lot more than I used to, but I still can't go and work out what that model does and whether it's good or not. But we need to give our skills as developers to people who don't necessarily have that background. And what we've done is, I was saying we can export the model, so you can run PowerShell and it will export that web service as a resource template. I can then go and deploy that resource template in a different subscription. It gets a different URL, it gets a different key. There's a couple of things you have to do because it uses a storage account, so you'd have to go and edit that or parameterize it so you can put your own storage account in. And if there's any in the model, you can actually store data in SQL if you want. So our data scientists have been putting data in SQL themselves. So we need to change the connection string as well when we move it over. So there's a few parameterization things you need to do. But what that's allowed us to do is have that resource template, deploy it out into our test environment, connect it up to our services and get them get them testing it without it affecting any production stuff. And when we're happy with it, we then import it into a different subscription in Azure, and then have a different web service again with a different URL and different key, which goes in our prod environment. So that's all as its resource templates just text. We check that in, so we've got that a bit more rigor in there. We can automate that if we want to. We can do we could automate the PowerShell export. We could parameterize it, and when we deploy it, it will go in the right environment, in the right place. So what we've done is allowed them the freedom to do what they want, which is one of the problems we had previously. It was we were building the models. Basically, they would say, this is what I want, and then we'd write it in C# or JavaScript or whatever and get it wrong, and then they'd say, no, that's wrong, you've got to tweak that, you've got to tweak this. So what we've given them is the control to build it themselves, but the rigor from us so that we don't break everything when they get it wrong. And we're still working on it. It's not perfect yet. We've still got quite a lot of manual processes in there, but we've got that. We've got those distinct steps now. And so from a development point of view, there's a lot of things out there now where people have already built models for stuff that you can just use. So if you look at Cortana Intelligence Gallery, there's a whole load of stuff in there that people have built, so you can import those into your models. And for example, one of the things I've been using, there's a Q&A maker, which uses a Q&A matching, and you can actually build chatbots based upon some machine learning with question and answers and stuff. That's really useful. But the one I've used quite a bit is Azure Cognitive Services. So they've built a lot of models around things. So there's 29 different. Actually, that might be changed now. That changes every week, that number, 29. But last time I looked, there was 29 in 5 different groups. So the ones I've looked at is the vision one and the language ones mainly. But there's speech, so there's text to speech and speech recognition, that sort of thing. There's a whole load of Bing search ones and maps and that sort of thing. But the vision one is really good because it's face recognition of it will look at a photograph and work out where your face is. It'll be able to tell you where it thinks your eyes are, whether you've got hair, whether you haven't, whether you've got glasses, sort of a rough age, not always right. It can actually detect whether it thinks you're happy, sad. There's quite a good lot of things in there, and it gives you coordinates as well, so you can look at like your eyes, what coordinates your eyes are, and a few things. It also does vision, which is looking at an object and trying to detect what that object is. And then with the speech stuff, you have speaker recognition, so it'll be able to identify who's actually doing the talking. It'll be able to translate it. So I've seen a demo where somebody's doing a presentation like this, and they've got Bing Translate on there, and it's actually doing subtitles in a foreign language based upon real-time speaking, I suppose. Then we've got language. So language understanding is a module that's basically you type some text and it tries to find meaning out of that text, and then you can perform actions on it. Spell check, translation. Translation is quite good. I think if you came to my talk, the last one I did, which was Logic Apps, we used Translator to do a hello world in Czech. So that was sort of just passing it in through the translation API. The knowledge stuff, I've already talked about Q&A maker, so I've used this. You write a load of questions and answers, put it in a thing, somebody writes a text in a chat bot, then it comes back and gives you a set of answers based upon what they wrote. And then there's a whole load of other stuff. So we'll do a couple of demos. So the first one is, if we go to Cognitive Services, they've got a really nice set of samples they can use. So these are all the different groups we have. So computer vision, so you can actually do some demos. Some of these demos will ask you for it. Are you playing again with your phone? Have I dropped out? I've dropped out somewhere. Quite like having a backing track. It's quite nice. So computer vision. This is image scene detection. So, you've got a whole load of pictures you can sample. You can upload your own. but it produces a whole set of data related to it. So this one, it sees it as a train with a platform, station building. So it's giving you a whole set of words what it thinks. Then it's got people waiting at the train station, and it's got that confidence factor. So it's basically the same thing as that I showed you with the prediction stuff. You get a value, and a whole load of other stuff. So if we looked at this one, for example, this one's come through and it says it goes group of people posing for a photograph. It's picked that out. So so all these have basically got an SDK. You can write programs with it, and I used where do I want to go back? So the face recognition one is quite nice. One, so you can see again, this is picked. I've picked this image. It's got the face. It shows you the rectangle, which is that box coordinates. Bald, no. Is that what it's saying? Hair colour, brown. So it's not quite sure by the looks of it. It's come with a number of different answers on hair colour. Oh, it's tried them all, I guess, and it's the confidence is that it's brown, so it's a high percentage. You can see the angle of the head, female, age 24, reading glasses. So there's quite a lot of different things. So if we pick a different one, for example, it's found all three faces. Now I've used this before. I don't know. A while back, I did a talk with Raspberry Pi and used face recognition to use it as unlocking a door, and I use this algorithm, this process. It's really good. The only thing you need to do is this is face recognition. You can do face detection as well. So, but face detection needs training. So I had to pass in loads of photographs of the people I wanted it to pick. So I put pictures of me in there, put pictures of my wife in there, and I didn't put pictures of my daughters. And I uploaded a picture of my daughter to test, and it came out as she thought it looked like a mum. So I got a bit of grief for that. So I had to upload photographs of her just so that it then. But once I did it, it recognised it was her. So every time it didn't then confuse. So it is one of those things. Some of these services, like this service, the face detection one, you don't need to train. Whereas the face recognition one, I said there isn't a demo for that because you need to train it. With all the others are generally here's a set of things that you can do with that. So the language understanding one is another one that's quite useful. So we could actually just pick one of those. So turn the right light on. So I click that, and it's got it does that. Or we can say switch the floor lamp to green, which is that one. Switch all lights to green. I don't know what. Turn table light off. So we can put. So I could actually go in here and say, turn floor lamp off. And that's turned it off. So it's not. I haven't picked something that they've already got. Turn floor amp. Does it do different colours? No, it doesn't know. Obviously, only has a few sets of colours. Oops. Is that green? That isn't green, is it? I'm not dancing, but yeah. So what this has done is it's taken the quick. If we look at what it's done here is it's taken the command that we've entered, and it's looked at what the intent is for this message, and this is saying turn all on, and it's thinking it's a 96%. 96% certainty that's done. And what it's also done is it's looked at the entities within there. So it's got an entity green of type colour, so it's picked that out. And it's given that again. It's given it a 99% certainty. So what that's saying is, I want you to turn all the lights on and make them green. So it's used the text I put in, and it's used machine learning to actually determine what the action is and what the thing is I'm trying to do. So if we do, so this is again, this has done something similar. So this is said turn on, because I've just picked turn left light, and it said entity left of type light, and again it's a high percent. So if I just try, let me just zoom back out. So turn on left light, turn left light. Let's see whether this does. It hasn't. I expected it to put another entity of colour in there, but it hasn't. It also hasn't turned it green, has it? So switch floor lamp to green. What does that? Yeah. So that has got. I obviously didn't type the right thing in. So that says intent is to turn on, and I've got which lamp is it? It's a floor lamp. And which colour is it? Green. So it's picked out of the words I've done, the intent and the two different things that I wanted it to do. So that is that, I think. I've done it again, I've jumped ahead, haven't I? So I've already talked about this. So analysts aren't used to doing developer quality stuff. They're used to just building stuff in Excel and giving people dashboards or whatever. So one of the things that Azure ML gives them is that ease of deployment, which means that it's easy for them to make mistakes. It's also easy to get your workspace messy. So you saw mine, I'd only got about 4 experiments in there, and then when you start deploying them, you get another one, and it starts getting a bit messy. So, and it's easy to sort of make, well, it looks like it's easy to change and redeploy, but obviously mine didn't work, so that wasn't that easy. But Azure ML, without doing the exporting stuff, there's always a number of things that you can do. So you can have different workspaces. So you can have free workspaces. So you could give your analysts or you or whoever the free workspaces, and when you've done your messing around, you want to do something with it, you can copy that into say a test one, where you could do maybe peer reviews and you can do testing in that environment in a different workspace. You can also save experiments to different names, so you've got a bit of version control, I guess, but that's down to the individual to make sure they do something. There's nothing there that enforces it. But when you do your run history, you'll be able to go back and see. So every time you've changed it, you'll be able to see what happened and what the results were. So you do have a bit of history baked in. So I think one of the things we were thinking of doing is we could just have a number of different workspaces. So instead of exporting everything in PowerShell and doing the CI type approach, you could say, right, you as an analyst can do your development in here, then move it to a test one, which everyone's got access to, where you can do shared testing and with a shared set of data, and people can do peer reviews. But when we want to push it into a production environment, only certain people can then copy it. So there's a bit more control. So you don't have to do the exporting of data using PowerShell. If you don't want to, you could do that way. But it would be also useful to have a sensible naming convention for individual experiments. So one of the things we've done is we've got a number of different versions, or we've just been putting version numbers on. Just as they can call it whatever they want, but make sure that at the end they have version 1, version 1.1, and version 2. Because that way we know when we're trying to export it which one they're doing, and when we're talking about it, everybody knows which version there is, and it makes it so much clearer. But I thought that's what I just talked about. But the whole bit about exporting it, what we've done is actually we've set it up to run in parallel. So we have one that's in production. We also have one in a staging slot. So when we're running our web service, we have one that is run, that is the production one, and that will take the output, and we'll use that output in our application. But what we also do is run one in parallel, but we don't use the output of that. But what we would do is be able to track whether that's giving us an answer that's better. We expect it, because it's a newer version, we expect it to be a better answer than one we've got. So we've got a way of comparing that data. So whilst we're trying to give them as much flexibility as they can get, we didn't need a way. Sometimes the only way to test these things is with real life data. We've got test data, and a lot of our stuff is based upon people and getting credit histories and all that sort of stuff. So you're not going to run loads of tests on people's credit history, because that's not a good thing to do. And actually a lot of the data we have is all fake. So when you try and do searches and get real life addresses and stuff, it doesn't come back with the right answers. So testing the test environment's not that straightforward. So we started running stuff in parallel and evaluating the results. So we'll run for say 2 weeks with that model and see what the answers are. And our analysts can go and look. That's why we store it in the SQL. They store the answers in SQL, compare with what the real one is, and make sure that there's actually what they think. And that seems to be working quite well. I've blogged about this, so if you go on my website, you'll see that I've talked about how we've set up the web service deployment and what we've exported them and the PowerShell, that sort of thing. So this is the end. So Azure ML allows you to build and test and deploy really easily. It's really easy to set something up. But I think for me, I've learned a lot from the data scientists, talking to them, explaining to them what I'm trying to do and what they're doing. So teaching the engineering principles, which they've benefited from. They've also taught me what a lot of the data science side of it is. I still don't understand it, but I know I'm getting to that point where I know enough to be dangerous. So I can do the same as they do to me when everybody knows about how to program and how to build stuff. I can do the same to them now, so it's quite nice. We've actually started to try and automate and test the deployment. So that whole thing, the whole sort of building stuff in a way that's repeatable and testable is what we're trying to do. So that's it.